right, y'all come back? Did y'all make it back? Say hi to me again let me know you're here. Let me know you're back. Let me know you're back. Let me know you're back. Do your early bird. Do your early bird. Let me know you're back. Are you here? Are you here? Are you back? Did you make it back? Are you back? Are you back? Did you make it back? Who's back? Who's back? Hi, Thomas. Way to come back. Do that early bird. I bet you can do that. Who else is here? Who else is here? Let's see. Who else is back? Is Gladys back? Who else is back? Amanda's back. Thomas is back. Where are the rest of them? Austin's back. Yay! We can start now. That's all that's important. Thomas and Austin, that's enough. Hey guys. Y'all here? Ugh. Marissa, yay! Marissa's here. Who else? Who else? Who else? Y'all do this early bird while we wait for everybody to get here. I need one more and then I can juggle. Hey, there's Cheyenne. Yay! Got your drinks in hand. I think Rachel said she was going after an adult beverage. That doesn't mix with math, just FYI. Doesn't help you out. Does not make it easier. Wait, there's another one. Let's see if I can juggle. No, I can't. The answer to that is no. I can't even do two and catch them every time. Let's just try two. No. Can't even do two. No, I don't know how to juggle. Maybe with balls? Something about these markers are harder. Maybe it's because I'm flipping them. No, I don't know. Hey, Rachel's back. Hopefully with no adult beverage. None of that, none of that. Math is hard enough without it. All right, y'all ready to get started? So we finished up the definition of logs. You're going to need that for this one too. So hopefully we now know that the logarithm is just an exponent. That's all that really means. So a logarithm is just an exponent. No big deal, we got this. So now, what we want to do is learn about the rules or properties of these exponents. We're just going to learn about these rules or properties of the exponents. And because they're just exponents, they actually follow the rules here. So yes, September, good job. That's just equal to z to the fourth. Because remember, this is 6 of them. 1, 2, 3, 4, 5, 6 over 1, 2. We're really just subtracting those off, right? These two are just, it's really 6 minus 2. We subtract them off to get z to the fourth. And you're right, here, x to the fourth times x to the 3 is just 1, 2, 3, 4, 1, 2, 3. Remember with those exponents, we're really just adding them to get x to the 7th. And then good on this last one, remember this is just y to the 5th times y to the 5th. Or that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 10 of them. Really what we're doing is 2 groups of 5. So we could just multiply. 5 times 2 equals 10. Okay, because because logarithms are exponents, these same rules are going to apply. When we are dividing, when we have a quotient rule, we're going to end up subtracting. When we are multiplying, we're going to have a product rule where we add. And when we are raising it to a power, we're going to have the power rule where we just multiply. It's these same rules that we've already learned with exponents. The exact same thing. So I'm going to start. Let's start here with, I don't know which one. How about this one first? No, let's do the quotient rule first. Let's do the quotient rule first. Quotient rule first. So let me give you an example of the quotient rule. Here I have log of 1,000 divided by 10. Man, already. How sad. Oh well. Haters gonna hate. So here we got 1,000 divided by 10. Well, let's do that math first. Let's just do that math. 1,000 divided by 10 is just equal to log of 100, right? The zeros go away and it just leaves me with 100. So what is log of 100? 10 to what power gives me 100? You can probably answer that. I bet you remember from just 5 minutes ago. 10 to what power gives me 100? So 10 times 10 is 100. So it's just equal to 2. Yeah, it's the 2 it's equal to. You got it. Okay, so I'm going to show you how we can use the quotient rule for this. So what the quotient rule says is that when I have two numbers dividing, see how these two are dividing? So I'm going to put it in like general terms. The quotient rule says that when I have log of some number divided by another number. So in my argument, it's dividing. Then it's log of the top number minus log of the bottom number. Rachel, I hate it when we have lag. Drives me crazy. Sometimes it's on my end, sometimes it's on y'all's end. There's no telling. By the way, that's always my excuse when I'm gaming too. I'm like, the lag is real tonight. Okay, so log of the top number minus log of the bottom number. So I'm going to use that rule here and I'm going to show you that it actually worked. Notice, really, it's just exponents. So it's an exponent minus an exponent. So here I've got log of the first one minus log of the second one. So I'm going to show you that it's equal to 2 either way. So what is log of 1,000? That log of 1,000. So 10 raised to what power gives me 1,000? I know, right? Maybe we'll learn some math. I'm all about learning math. This is what I would do too, is hang out on somebody's live stream that's streaming math. It's a favorite thing to do. So 10 to what power gives me 1,000? That's 3, because 10 times 10 is 100 times 10 is 1,000. 3 of them. Minus log base 10 of 10. So 10 to what power gives me 10? This is just a fancy way of just saying 1. So 3 minus 1, sure enough, is equal to 2. notice that using the quotient rule, I got the same answer as that. So it's just that exponent of 2. I can, since they're just exponents, I can use that same quotient rule and subtract them to get the same answer. So the quotient rule just says when I have 2 in my argument that are dividing, I can take the log of the first one minus the log of the second one. All right, let me do another example using that quotient rule. What if I have log of e to the third power over 7? So I'm going to use my quotient rule to help out. Not log. I'm sorry. I'm in natural log. Natural log. Read it as the natural log. Natural log. So, the natural log here. By the way, not everybody made it back. If you made it back, be sure to let me know that you're here. Say, I'm here. So like, I see most of y'all, Marissa, September, Cheyenne, but I'm missing out on Jacob and Cherish and Fernando. Who else? So the natural log of e cubed divided by 7. So I'm going to take the natural log of my numerator and subtract the natural log of my denominator. So I can use, oh, there's Jacob, okay, good. I'm going to use that natural log of my numerator minus the natural log of my denominator. So now, e to what power, that's what this is. If I can evaluate it, I'm going to. So e to what power gives me e cubed? E to what power gives me e cubed? You remember from earlier? E to what power gives me e cubed? Great, learn a log. Perfect, guys, e to the third power. So e to the third power, so this is just a fancy way of saying 3. Now this one's not so pretty. E to what power gives me 7? Remember when we talked about e, we knew it was about 2.81 whatever? And e squared was about 7.2. Remember graphing those? This natural log of 7 is somewhere between, it's really close to 2, but not quite there. But it's not a pretty number, so we're just going to leave it as the natural log of 7. Its exact form is there. So we've used our property, though, there to show that quotient, and anywhere we could evaluate, we did. All right, so there's the quotient rule. Let me show you another rule. Let's do next the product rule. So the product rule, I write it over here too. The product rule, and we'll leave it there. The product rule says that when I have some log where inside my argument you have 2 things multiplying together, we're going to take the log of the first one and add it to the log of the second one. So there's the product rule. Take the log of the first one and add them to the log of the second one. All right, this was natural log of e cubed minus the natural log of 7, or 3 minus the natural log of 7. Okay, we're going to use this product rule next. So the log of that inside being multiplied is equal to the log of the first one plus the log of the second one. All right, let's do it. So here's an example. I have log of 10 times 100. Log of 10 times 100. Well, we could do it this way, where we just multiply that out. Log of 10 times 100 is just 1,000. So what is log of 1,000? Oh, we saw that earlier. It was just equal to 3. So that's just equal to 3. Now I'm going to show you that the product rule works as well. So I can take the log of the first one and add it to the log of the second one, because they're just exponents. So when the when the arguments are multiplying together, the exponents just add. Y'all totally have got this so quickly. Usually it takes them a while, doesn't it, Amanda? But they're already like popping off numbers fast. So log of 10 is just 1 plus log of 100. 10 to what power gives me 100? Well, just 2. So 1 plus 2 is 3. Notice either way I got 3. By the way, when you have 10 and you're raising it to some power, look, you can count the zeros. 1, 2, 3. Look here. 1, 2, 1. So if I give you something like this, log of, we can just count the zeros. 10 to what power gives me 10 million? Well, it's just 1, 2, 3, 4, 5, 6, 7. This is just a fancy way of saying 7. So anytime you're dealing with log with a base 10, and you've got a nice pretty 10 in there, just count the zeros and it'll tell you what it is. It makes it a little easier. Okay, so this is that product rule. How do we use the product rule? Let me give you an example of the product rule. So what if I do log of 10x? Yes, logarithms are definitely used in chemistry. Definitely used in chemistry. So logarithms are an actual thing that you use. This week, maybe in your application exercise, you'll be able to see a little bit about why logarithms are used. Maybe, we'll see. If it helps you to understand a little bit why they're used. By the way, did Robin come back? I haven't seen Robin back, and I haven't seen Cherish back, and I haven't seen Fernando. Did you guys make it back? They went and got their drink and never came back. Okay, in this case, I have log of 10x. I'm going to use that product rule to help me. So I'm going to do log of the first one plus log of the second one. Did he make it back, Austin? I haven't seen him. Where is he? So, log of 10, oh, there he is. Hey, Robin, you're back. Yay! Just making sure. Log of 10 is 1. I want to be able to give credit where credit's due. So here I used that to break those two up and add them. So the product here, you can do the log of the first one plus the log of the second one. And then once we have that, we can do the exponent. So log of 10 is just 1. Now I can't do this because I don't know what x is. I can't simplify that, but I could evaluate this part. And now, One thing with the parentheses in the argument, notice that I started putting parentheses around my arguments. Here I put a parentheses, but here I didn't. Here I didn't. Here I didn't. Here I did though. So why am I putting them some places and some not? Well, those parentheses are really important, especially when you have more than one thing in your argument. So for instance, if I had written log of just 10x, that's something different than log of 10x. These two things are different. Those parentheses are a big deal because this just means log of 10, which we just saw was equal to 1, times x. So this is just equal to x. Whereas up here, they're both inside the argument of the log. So they're both being affected by that log. So it's log of the first one plus log of the second one. So yeah, the parentheses are really important. You've got to pay attention to the parentheses. So if you have two things in your argument, be sure and put parentheses around it. Okay. What else? All right, so there's the product rule. We've done the quotient rule and we looked at the product rule. Now I'm going to show you the power rule. So the power rule, when I have inside my argument, I've got some number, and I'm raising it to some power. So just like we had with the y to the fifth to the second power, then this y to this to that is equal to, I can multiply this exponent times that exponent. So I'm just going to multiply this exponent times that exponent. That's called the power rule. What if the parentheses, they both have exponents being multiplied? Do we do that, then the rest? Yeah, we'll get there, we'll get there. That's kind of what I'm doing, this power rule. But the exponents are going to be important. In fact, this power rule is going to help us out with that. So for instance, let's say I have log of 10 squared. We could just do the exponent. We could just say 10 squared is equal to 100. And so log of 100, well, 10 to what power gives me 100? Well, it's to the second power, so that's just equal to 2. I could just do that. Or I could take this 2 and use my power rule and say this exponent times that exponent. So I could write it as 2 times log of 10. Because log of 10, oh yeah, that too, Austin, you're exactly right, because when their bases are the same, their exponents are the same, so we know it's just equal to 2. You're exactly right, bases are the same, the exponents are the same, good. But here's another way to show it. 2 times that log base 10, well, 10 to what power gives me 10? This is just a fancy way of writing 1. So I have 2 times 1 is just equal to 2. So whichever way we do it, we end up with 2. So the power rule just says I can take that exponent and plop it out front so that this exponent is multiplying times that exponent, because they're just exponents. Well, Robin, if it's just on the outside like this, then that 2 is still on the 10. But if I wrote it like this, then I'm squaring the whole number. So again, those parentheses and where they are important. This just says I'm squaring the 10. This says that I'm squaring that whole, well, this is just 1 squared, which is just 1. So it depends on where outside the parentheses it is. And you got to look to see what all's in the parentheses, because this, you know, that parentheses means it's this times itself. And this one, it means it's this times itself. All right, so let's use that product rule, the power rule again. Let's look at the power rule again. Let's do this one. Okay, I'm going to use the power rule first on this one. So if I use the power rule, I take my power, it's being raised to that power, and I can plop it out front, or I can multiply it out front. So I have negative 8 log of m. So that those two are multiplying together. There I use the power rule. But I bet you guys remember what this negative 8 means. It means 1 over m to the 8th power, right? These two things are the same. Well, in this case, I could use my quotient rule, because now I have this thing that's dividing. And I'm going to show you that it doesn't matter. It's still going to be the same thing. That's right, Cheyenne. It's in the denominator. That's exactly right. So I'm going to show you that it's going to be the same answer whether we use this quotient rule or we use the power rule. So here, I do the quotient rule. I do the log of the first one, of the top one, the numerator, minus the log of the denominator. So the log of my numerator minus the log of the denominator. Now what is log of 1? 10 to what power gives me 1? Do you remember anytime that 1 is in my argument, what's it equal to? Excuse me. Anytime 1 is in the argument, it's equal to 0. That's right. So 0 minus log of m to the 8th. Well, 0 minus anything is just that. So it's a negative log of m to the 8th. But now we can use that power rule to make that multiply times this. So I have a negative 8 times that. So notice we ended up with the same thing that we did here. Anytime it's in the denominator, it's going to end up with a negative out front because it's a negative. When it's in the denominator, it's a negative exponent. So it makes sense that it's going to have a negative out front when it's in the denominator. Okay, we're going to use these 3 rules to expand our logarithms. So your instructions on the properties of logarithms homework is going to say to expand the logarithms. So, for instance, if I give you this one, we're going to expand that logarithm. And when we're expanding, really every time you're going to want to look to see, do you have a quotient rule first? That's what you're going to look for first, is your quotient rule when you're expanding. So here I have a quotient. I'm going to use my quotient rule to help expand my logarithms. So I'm going to do log base 8 of the top minus log base 8 of the bottom. Then every time I'm going to look for a product rule. So first I look for the quotient rule, and then I look for the product rule. Stop drinking, because drinking will do that to you. Once you've had too much, then it makes you barf. So I told you math and drinking doesn't mix. Don't do that. Oh, I think you might have it. I think. So this log base 8 of 64, maybe before we do that, let's rewrite this with an exponent. I'm going to leave this alone for a minute. Can't I rewrite this with an exponent? Cheyenne told me that this is raised to the 1/2 power. So I can use my power rule to then multiply. So anytime we have a square root, you're going to want to go from the square root to the 1/2. And if I give it to you with the 1/2, you're going to need to end up with the square root. You need to be able to go back and forth between these. Sure. It's just the math causing it. It could be. I'll be on Discord in just a little bit. It'll be all right. It'll be all right. It'll be all right. It's really hard to do both of these back to back, because usually you have a little bit of time to get your mind wrapped around what is a logarithm with that first homework, and then you bop into the properties one after you've had your mind to get wrapped around it. We're doing it back to back, and it's going to make it really tough. But you can do it. You can do it. Oh, migraines are bad. Migraines are really bad. Math and migraines don't mix either. Okay, what is this log base 8 of 64? In other words, 8 to what power gives me 64? Well, 8 times 8 is 64, so it's just equal to 2. Here, I'm going to use the power rule to kick this back out front. So this power is going to go right out here. And I'm pretty sure that's what Cheyenne told me. Maybe she didn't do this part, but it looks like that's exactly what she had. Had that totally right. Now, here's the thing. Don't try to combine these. We have to do this multiplication before we can combine these. In other words, this is some number. We don't know what that number is, but it is some number. And I have to do 1/2 times that number before I can subtract it from 2. So you can think of it as these two are not like terms. This 1/2 has this number on it. The 2 doesn't have that log base 8 of x plus 1s on it. You cannot combine these. This is it. This is as far as we can go. Stop there. Stop. Until I know what x is, I can't do the rest. Freeze. All right, let's do another one. All right, let's do, how about log base 6 of, let's just do x squared y cubed. Okay, the first thing we're looking for is a quotient. Do we have a quotient in this one? Do we have a quotient in that one? Yeah, no quotient happening. It's not dividing. So then I look for the product. And we have a product. This and that are multiplying together. So this times that, I'm going to take log of the first one, x squared, and I'm going to add it to log of the second one. This may be the one. Now, I've done the product rule. Now I'm going to use the power. Good, September. See, you're right with me. So now I'm going to take this 2 and kick it right out front. So log base 6 of x plus, make that 3 times the log base 6 of y. I don't know what x and y are, so I can't do anything more. That's it. Done. That's it. No more. Y'all are funny. All right, how about this one? Maybe I'll make it harder. Let's do this. I bet you can do this. The cubed root of x times y to the 4th all over, let's put it over something fun like 1,000. I bet you can do that one. Sure it is. Challenging. If you can do this one, you're in good shape. You got this. Okay, first thing we look for is the quotient rule. This time I have a quotient. I have a numerator divided by a denominator. I have a quotient. So I'm going to do log of the top. Again, those parentheses here are important. The whole thing's in the argument. Log of the top minus log of the bottom. So anything in my denominator is going to end up with a minus in front of it. Hey, look at September. She knows this is just equal to a fancy 3. That's just a fancy way to write 3, because 10 cubed is 3. But notice inside of here, we got rid of the quotient rule. Now we're looking for the product rule. And sure enough, I have a product. Woot! Way to be, Marissa. Because you're right, this is a product. So I can do log of this one. And she even said, remember that this cubed root is just a 1/3. Plus log of the second one. So y to the 4th. And then last but not least, we're going to kick out those powers. So kick those powers out front. So that I have 1/3 log of x plus, kick that 4 out front, 4 log of y, and yes, minus log of 1,000, but you know that's just a fancy way to say minus 3. You got this. See, even with the challenging one, y'all got this. One last really challenging one, and then we're going to condense them. So the hardest one you'll see. See if I have an example of the hardest one you'll see. No, I don't. Okay, so I can make one up. Okay, how about log base, I don't know, your favorite number, 5. And we'll make this one the hardest you'll see. How about z squared over x to the 3rd power, y to the 6th power. That looks fun. When you are expanding, you're going to want to do it in that order. Yes, you're going to want to go quotient, product, and then power. So yes, when you're expanding. In a minute, we're going to condense, and then we're going to go backwards. But when we're expanding, you're going to want to look in that order. So first thing I'm going to look for is that quotient rule. So we have a quotient. I'm going to do log of the top minus log of the bottom. So log of the top minus log of the bottom. And when I do the bottom, it's this whole thing in there. So I'm putting parentheses to show that it's the whole thing. Y'all are going to not do this, and I'm going to take off. So put those parentheses. And by the way, for those of you who are not showing every step, make sure you're showing me your steps along the way. And for those of you who are using some sort of online tool, I can tell your notation is weird. I don't think anybody on here is that person. Last week I got some weird stuff. I can tell when y'all are doing things you shouldn't be. I especially love it when you just copy somebody else's sheet and this little 3 in here becomes 3 to this, that becomes that. And I'm like, Somebody didn't understand what they were writing down. It's true. I know that too, Austin. I tell y'all, I know everything. Y'all don't know that I was a student once too. That's right, don't do them. And just, instead of going through the effort of cheating, just learn the material. It's so much easier. All right, here I'm going to do log base 5 of this minus, here I've got a product. Now this one's tricky because this whole thing is being subtracted. This whole number. So to show that, I'm going to have to put big parentheses around this. So that I have log base 5 of the first one plus log base 5 of the second one. Now, why did I do that? Why did I put these big parentheses? Because this negative has to be distributed to both of those. So I have log base 5 of z squared minus log base 5 of x squared minus log base 5 of y to the 6th. Notice, both of those were in the denominator. So they should really have negative exponents. And so when we distributed that, that's what happened, is they both ended up with negative exponents. Then I can use my power rule, so kick it out front. 2 log base 5 of z minus 3 log base 5 of x minus 6 log base 5 of y. It's true. I never did anything. Y'all, I told y'all that story. I didn't even know what marijuana was. I had to call somebody in to look at it. I told y'all that story. I don't know anything. I'm so innocent. Naive. Wait, you got it? Good. Check that out. There it is. That's the hardest one you're going to have. Okay, now what we're going to do is condense it. Okay, so now we're going to condense the logarithm. Condense. So the first half of your homework on the second one is going to say expand it, and the second part is going to say condense it. Really? Your English teacher told the same story? I don't believe that. Really? I can remember the kid who told me, I can't remember his name though. What was that kid's name from Waco that told me there's drugs in the bathroom? Can't remember his name. Okay, so now I'm going to condense it. What do I mean by that? Well, I'm going to give it to you like this. Oh, this is a 3. Log base 3, log base 3. Log base 3 of 405 minus log base 3 of 5. Oh, we found it on the park on the way home from school. So one of our English teachers is just as naive. I thought that was just me. Naive and dumb. Ignorant. I was ignorant. There's another English teacher out there like that, huh? Oh my gosh, that's crazy. Craziness. Craziness. Is that in Moody, Cheyenne? Because you know I taught there, and so did Amanda. I mean, A. Simpson. We both taught in Moody. Sounds like a Moody type of thing. Hey, log base 3 of 405 minus log base 3 of 5. So what we're going to do is we're going to use our rules to go backwards so that we only write log once. So here I had log once and I expanded it out. When I condense, I'm going to go backwards. It's just the same thing, only going backwards, so that I'm only writing log one time. You went to Moody in elementary? Both me and Amanda taught in Moody. So let's see. When you were young enough, I might have been there. I might have been teaching in the high school when you were in elementary school. It's a possibility. And I went to Moody myself in elementary school. My mom used to teach there too. So if you have anybody that was there when a long time ago, they might have had my mom for math in Moody. Great little school. Okay, so here, I'm going to use my quotient rule. Now, before I do that, I just want to show you that you guys have learned a little bit, okay? So we know that these logarithms are exponents. So I'm asking myself, 3 to what power gives me 405? And it's not a nice, pretty thing. If I start multiplying by 3s, 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, times 3 is 729. Oh no, I passed over that 405, didn't I? So it's somewhere between 5 and 6. Thanks, Robin. It's a logarithm. So somewhere, this is about 5 and a little bit. This is 5 and a little. If you were to put that in a calculator with a base 3, log base 3 of 405, you'd get 5 and a little bit. Minus this log base 3 of 5, well, 3, the first power would be 3. 3 times 3 would be 9. So this is somewhere in between 1 and 2. You know, it's 1 and a little bit. So this is 1 and a little. Y'all with me on that? Does it kind of make sense? That I'm just trying to figure out the exponent. And these aren't pretty. They're some sort of decimal numbers. So 5 point something minus 1 point something. Okay, great. We could do it that way. Or we could use our quotient rule. So watch this when I do the quotient. I we used our quotient rule and I go backwards, the first one goes in the numerator and the second one goes in the denominator. So this 405 over the 5. Now, let's do some division. 405 divided by 5 is 81. That's equal to 81. Now, wait a minute. Log of base 3 of 81, I think that is a power of 3. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Hey, that's just equal to 4. That's a fancy way to say 4. Oh, look up here when we did it approximating. 5 and a little minus 1 and a little. Well, if the littles are the same, you got 5 minus 1, which gives you 4. When we approximated, we got that same answer. So, you know, we kind of get the idea of what a logarithm is. It's just this exponent is all it is. All right, let's do some more condensing. Condensing is just going backwards. That's all we're doing is we're just going backwards. So here I had the quotient rule that I used so I could write log 1 time. So here's another example. Log of x minus 7 log of y. Now we're going to go backwards from this. So the first thing we're going to look for is the power. We see a power on this one. See this 7? It's going to become a power on my y. So I'm going to kick this back so that I have log of x minus log of y. I don't have a product. There's no addition happening. But there is a subtraction, so I can use my quotient rule. So my whole goal when I'm condensing is just to write log 1 time, just once. And then I do log of the numerator over the denominator. So the first one becomes my numerator and the second one becomes my denominator. Anytime it has a minus in front, you know it's going to go in the denominator because that exponent is a denominator. Good, good, good. All right, 2 more. Let's condense 2 more. And then we'll jump on Discord and have a party. So 2 natural log of x minus 1/2 natural log of y. Wait, the 7? Oh, I don't know. Where did that 7 go? You're right. The 7 should be there. That 7 should be there. That's what y'all are saying. The 7, the 7, the 7. I don't know what happened to the 7. Good question. Just disappeared. That 7 went here. That 7 should have been there. Way to catch it. Good job. Good job. I just kept going and going and going. Y'all caught it, but I didn't. Good job. Okay, how about this one? Here, let's make this a plus instead. Just so it's something different. Let's make that one a plus instead. In which case, if that's a plus, first, power rule. Kick those powers off and try not to lose them. So all I did was kick that power there and that power there. We'll see if I can not lose the power this time. Don't lose your power. Hey, but this 1/2, we know that that's really equal to the square root of that. So I'm going to rewrite it. If I give it to you as a half, you need to end up with the square root. If you're given it as the square root, you need to end up with the 1/2. You need to be able to go back and forth between those two. So if the problem gives it to you this way, your answer needs to end up that way. If the problem gives it to you this way, you need to end up with it that way. Show me that you can go back and forth between those two. Okay, so we did our power rule. Next, we're going to do our product rule. So this plus sign, I'm just going to write my natural log one time. And then it's the natural log of the first one times the second one. Again, the parentheses here are really important. Don't lose those parentheses. Put those parentheses around your whole argument. How do you feel about this condensing? Once you can expand, condensing is just going backwards. I'm going to give you a really hard one. You ready for a challenging one? We'll do a challenging condensing. 4 natural log of x plus 7 natural log of y minus 3 natural log of z. By the way, their bases do have to all be the same. Like if I had written this last one, log of z, we can't use the quotient rule on that guy. He's different from that one. Their bases have to be the same in order for us to be able to use those rules on there. So just make sure that when you're doing it, your bases are the same before you start using the rules. All right, first thing we're going to do is look for those powers. Power rule first. So kick those powers back on first. So I got natural log of x to the 4th plus natural log of y to the 7th minus natural log of z cubed. That's step 1. After you've done your power rule, do your product rule. So anywhere you see a plus sign, make a multiply. Plus sign, multiply. So natural log of x to the 4th times y to the 7th. So that plus sign means that I'm doing the product of them. And notice I only wrote natural log one time for those two. So I did the power rule. I did the product rule. Now I'm going to do the quotient rule. Quotient rule. Write natural log one time. I'm only going to write it once. That's my goal. In the end, I only want it written once when I'm condensing. So natural log of that on top over the denominator. So the fact that it had a negative out front meant it was going to be in the denominator. The fact that they were positive meant it was going to be in the numerator. What do you think? How do you feel? You got this? All right, your job is to join us on Discord. We're going to have a party to get this homework done. Knock it out. Get it turned in. And then on Thursday, we just have one lesson. It's the equations. We're going to solve for x on Thursday. So in exponential and logarithmic equations. Good. I'm glad y'all are feeling better. And it's not too bad. And there are only a couple of graphs that you have to do for logs. On those, make sure that you do the exponential function first and then find the inverse to graph them. I think it's only like 3 of them. All right, I'll see you on Discord. Way to be here tonight. There were a couple that I never saw in the second one. So like, was Cherish ever here in the second one? Cherish, if you're here, say hi. And then I was also missing Fernando. I never saw Fernando come back. Fernando, did you come back? If so, say hi. Let me know you're here. I need to know that you're here. Jacob's here though. Food first. Food first. Okay. You can't just live off of math. It's not how that works. And then jump on. Eat and play at the same time. All right, for my sign off. Math made simple at Simpson Math. Thanks for watching.